Hi everybody! Today I can review skills from Algebra 1 by practicing. There's 3 skills we're going to learn today. One of them definitely comes up a lot more than the other 2, so that's the one we're going to talk about first, reducing radicals. Then we're going to talk about solving quadratic equations, and then we're going to talk about in terms of x. These are all things that you learned back in Algebra 1. They come up sometimes in geometry, especially in this unit, which is why we're spending today doing that. So, to reduce radicals, I need to separate into perfect squares and non-perfect squares. So I wrote out my list of perfect squares to my right, and all these numbers, where do they come from? They're numbers obtained when you multiply a number by itself. 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, etc. So I need to find the largest perfect square that goes into 45. So there's 2 ways to do it. We can do it with the calculator, we can do it without the calculator. Here's how I do it without the calculator. 45 would fall between here and here. Can I divide 45 by 36? No. Can I divide 45 by 25? No. Can I divide 45 by 16? No. Can I divide 45 by 9? Yes. So 9 is my perfect square, and 9 times 5 is 45. That's how I would do it without a calculator. Now, if you want to use a calculator, there's a little trick that you can use, and here's how that trick works. We're going to go to y equals. We're going to type in the number I'm reducing, so we're going to type in 45 divided by x. And you should have seen this trick last year in Algebra 1. I'm going to go second graph, which is my table. Now, I'm going to look in y1, and I'm going to find the largest number that's on my perfect square list. 45 is not on my list, 22.5 isn't, 15 isn't, 11.25 isn't, 9 is. 9 and 5 are my numbers, and the perfect square, the number from the list, always goes first, and that's why I wrote PS and NPS. PS for perfect square, PS for perfect square, and NPS for non-perfect square. That's step 1. Step 2, take the square root of the perfect square. The square root of 9 is 3. Not radical 3, not 3 and 3, but the square root of 9 is 3, and the non-perfect square comes down. That's how you reduce a radical. 50. I'm going to break it down into perfect squares and non-perfect squares. If I want to use my calculator trick, I'm going to go to y equals. I'm going to go to 50 divided by x. Let's go to my table. Look in my y1 column. 50 is not on my list, 25 is. 25 times 2. So my perfect square is 25. My non-perfect square is 2. That's step 1. And again, you don't need a calculator. 50 would fall here. Can I divide 50 by 49? No. Can I divide 50 by 36? No. Can I divide 50 by 25? Yes. So that's step 1. Step 2 is to take the square root of the perfect square. The square root of 25 is 5. My non-perfect square comes down. That's my answer. Rad 162. I'm going to break it down into perfect squares and non-perfect squares. If I want to use my calculator trick, I go to y equals 162 divided by x. Look at my table, look at my y1, 162 is not on my list, 81 is. 81 and 2, so the perfect square goes first, the non-perfect square goes last. Radical 81 is 9, the non-perfect square comes down. Now, radical 81 is 9, not radical 9. So I don't now make the 9 into a 3, because once I take the square root of something, the radical goes away. I'm done reducing that part of it. I want you to try 4, 5, and 6 right now on your own. So please pause this video, try 4, 5, and 6, and then turn it back on and see if you got them right. So at this point, please pause and try 4, 5, 6 on your own. Okay, now that you tried 4, 5, and 6 on your own, let's go over them. I want to break each of them down into perfect squares and non-perfect squares. If I'm using the calculator, I'm going to y equals, I'm doing 32 divided by x. I'm going to my table. 32 is not a perfect square, 16 is, 16 and 2. That's step 1. Step 2, the square root of 16 is 4. Non-perfect square comes down. Don't take the square root of 4 and make it 2. When you take the square root of something, the square root's gone. Now, what some of you might have done, let's do it in a different color. You might have said, well, I made it into 4 and 8, and I got 2 rad 8. So here's the problem with that. You did not get the largest perfect square that goes into 32. And because you did not get the largest perfect square that goes into 32, this can be reduced further, which isn't the end of the world, but it gets a little bit more complicated because now I have 2 numbers outside, I have to multiply them, and when I do, I end up with 4 rad 2. So it's not that you can't get the right answer if you started that way, but it's unlikely that you will. You always want to get the largest perfect square, which is why you always kind of start higher up on the list and work your way down. All right, 5, same type of thing. Even though 4 does go in, 4 is not the largest number on the list that goes in. If you use your calculator trick, 48 divided by x. 48, no. 24 is not on the list. 16 is. 16 and 3. Take the square root of the perfect square. Non-perfect square comes down. That's your answer. And finally, rad 75. I want to find the largest perfect square that goes into rad 75. If I'm using my calculator trick, 75 divided by x. 75 no, 37.5 no, 25 yes, 25 and 3. That's step 1. Step 2, take the square root of the perfect square. Non-perfect square comes down. So you have a bunch more examples to practice. I'm not going to go over them in the video, but practice it until you get it because you will be reducing radicals in this course. Next type of question from Algebra 1. Quadratic equations. I've got a little story to help you. Mr. X squared, he wants to party. Before he can party, all of his friends have to come over. So what that means is you need to bring everything to one side of the equation. So in number 1, you're good. In number 2, you're not, because that 45 is not at Mr. X squared's house. So you'd have to subtract 45 from both sides. And you get x squared plus 4x minus 45 equals 0. I don't like my 4s. I like them now. In number 3, is everything on one side? No. I would have to bring the 20 over. A squared minus 8a minus 20 equals 0. Once everybody comes over, they party, and they party with bubbles. What that means is we need to factor. So again, this obviously goes back to Algebra 1. To factor a trinomial, the variable goes in front for each. The first sign comes down. Negative times a negative is a positive. Now you're looking for 2 numbers that multiply to the last number, and then whatever this sign is to the middle number. So what multiplies to 6? Well, 1 and 6, 2 and 3. Which of those pairs subtracts to 5? Can you just make this bigger? Subtracts to 5. 6 and 1. Bigger number goes first. Once I factor, I need to set each factor equal to 0. So I'm setting y minus 6 equal to 0. I'm setting y plus 1 equal to 0. I add 6 to both sides. On this equation, I subtract 1 from both sides. On that equation, y equals 6, y equals negative 1 is your answer. You're going to always get 2 answers for these. Quadratic equations will always have 2 answers. Number 2, it's time to factor what multiplies to 45. And by the way, we can use the same calculator trick for this. You're just looking for something different. So if I want the numbers that multiply to 45, I'm going to do 45 divided by x. But I'm not looking for perfect squares. I'm looking to see which pair subtracts to 4. So 1 and 45 don't subtract to 4. 2 and 22.5 don't subtract to 4. 3 and 15 don't subtract to 4. 4 and 11.25 don't subtract to 4. 5 and 9 do. So 5 and 9 are my values. Bigger number comes first. Let's set my signs up first. X goes in front for both. First sign comes down. Positive and a negative is a negative. And what multiplies to 45 and subtracts to 4? We just said 9 and 5. Now I set each factor equal to 0. X equals negative 9. X equals 5. For number 3, it's time to factor. First sign comes down. First sign times the second sign. Negative and a negative is a positive. I'm looking for 2 numbers that multiply to 20 and subtract to 8. Why don't you take a couple minutes or a minute and try and come up with those numbers on your own. You can either list your factors of 20. 3 doesn't go in, 4 and 5. Or you can use your calculator trick and do 20 divided by x and look at your table. So I'll give you maybe 30 seconds or so to try and finish this problem off. Okay, which pair multiplies to 20 and subtracts to 8? 2 and 10 subtract to 8. Bigger number goes first. Once I factor, I set each factor equal to 0. A equals 10 is one answer. A equals negative 2 is the other answer. So when you see an x squared in an equation, bring everything to one side. Factor, set each factor equal to 0. And when you're factoring, it's always going to be 2 sets of parentheses. The first sign comes down. You multiply the first sign and the second sign for the second sign. A positive and a negative is a negative. Then you're looking for 2 numbers that multiply to the last number. And then if this is a minus, subtract to the middle number. If it was a plus, add to the middle number. You can use the calculator trick to help come up with those values. In this case, it was 9 and 5. Then you're setting each factor equal to 0. And when you set each factor equal to 0, essentially the sign ends up changing. I'm going to start you off on number 4, and then I'll let you finish it on your own. Mr. N squared, he wants to party. Before he can party, all of his friends have to come over. Are all of his friends over now? No, nobody's over. So we have to bring everybody to his house. The party's at his house. When you're solving a quadratic, bring everything to the x squared because we want the x squared to be positive. So I'm subtracting 3n and I'm subtracting 18. That gives me n squared minus 3n minus 18 equals 0. Now that everybody's over at Mr. X Squared's house, it's time to party. They party with bubbles, this giant machine that blows bubbles all throughout the entire house. That means your next step is to factor. I'm going to let you take it from here. I'm going to give you about 45 seconds to a minute. I'll give you a minute to factor it and set each factor equal to 0. Okay, if you need more time, feel free to pause it. Variable goes in front for each. First sign comes down. Negative times a negative is a positive. What multiplies to 18? Well, 1 and 18, 2 and 9. I'm just kind of counting up from 1, 3 and 6. 4 doesn't go in, 5 doesn't go in. That's all of them. Then you can use the calculator trick to come up with those values as well. Which of those pairs subtracts to 3? 6 and 3. Bigger number comes first. Set each factor equal to 0. N is 6. N is negative 3. So I'll let you do 5 and 6, for classwork/homework. Again, for quadratic equations with an x squared, bring everything to one side, factor, set each factor equal to 0. The final type of Algebra 1 question I want to go over is what I like to call in terms of x. Whenever you're comparing two things, more than, less than, double, you're going to follow this procedure. So when I see that Jamie is 5 years older than Amy, I'm going to start by listing what I'm comparing. J for Jamie, A for Amy. Whatever comes last, I'm going to call x. Everything else I express in terms of x. So if Jamie is 5 years older than that, that means 5 more than that, Jamie is going to be x plus 5. Whichever one comes last, call it x. Everything else expressed in terms of x. And by the way, this is a very, 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 very common SAT question. Now that I have my expressions, I need to come up with an equation to represent the situation. The sum of their ages is 19. So if the sum of their ages is 19, that means that Jamie's age plus Amy's age equals 19. Now that I have my equation, I solve it. I combine like terms. Get x by itself. And I get 7. Now make sure you answer the question. The question is asking how old is Jamie? Well, Jamie is x plus 5. So Jamie is 7 plus 5, which is 12. The important thing is a step 1 right over here. When you're comparing two things, list the two things you're comparing. Whichever one comes last is just x. Everything else is expressed in terms of x. And from there, you utilize those values. Jack's age is 6 less than double Jill's age. So I'm comparing Jack and Jill. So since they both start with a J, I won't be lazy. I'll write Jack and Jill. I need to call something X, just X. Which one do I call X? Jill, because Jill comes last in the sentence. Everything else I express in terms of X. If Jack is 6 less than double that, this goes back to 8th grade math, translating into an expression, double would be 2x, 6 less than that would be minus 6. And if you remember, when you see the phrase less than, you kind of switch the order. That's really the thing I'm concerned about as far as what you're going to be doing in geometry, but I will finish the problem off from here anyway. If the sum of their ages is 30, that means that Jack's age plus Jill's age is equal to 30. From here, we do the algebra to get x by itself. And when I do the algebra, I get x to be 12. It's asking for Jill. Jill is 12. So, the three things that we talked about. One, the most important, what's going to come up the most in geometry, reducing radicals. Break it down into two radicals, perfect squares and non-perfect squares. Find the largest number from this list that goes into it. And again, where are these numbers coming from? 1 times 1, 2 times 2, 3 times 3, 4 times 4, etc. Once you break it down to perfect squares and non-perfect squares, you take the square root of your perfect square, that goes outside, and then the non-perfect square comes down. We then talked about quadratic equations. I like to call him Mr. X squared. He likes to party. Before he can party, all his friends have to come over. So everything has to come over to one side. Once I have that, I factor, 2 sets of parentheses. The variable goes first in each. First sign comes down. Multiply the signs. Positive and a negative gives you a negative for the second. You're looking for two numbers that multiply to the last number. You can list them. You can use the calculator trick. 2 doesn't go in, 4 doesn't, 5 does, 6 doesn't. Which pair subtracts to 4? 9 and 5. Bigger number goes first. And then from there you set each factor equal to 0 to get your values. And the final thing we talked about, in terms of x, whenever you're comparing two things, list the two things you're comparing. J for Jamie, A for Amy. Whichever one comes last is just x. Express everything else in terms of x. 5 older than that is x plus 5. And then once you have those expressions, you would just do whatever it says to do with them. Geometry, for what we're going to be doing, is really just coming up with this that you're going to need to be able to do. Your classwork/homework is to finish this worksheet to get comfortable with these Algebra 1 skills, because we're going to be using them with candy corn problems and Hill-Sass problems and other problems throughout the course of this year. That's it. That's all I got for you. Your classwork/homework is to finish this worksheet, and I hope you get comfortable with this stuff so you'll be able to do the coming lessons in similar triangles. Have a great day.